A heavy stone was pulled up a ramp inclined at an angle of 9 degrees. Approximate the distance the stone was moved in order to raise it to a height of 30 feet. Well, I'll sketch a picture to describe the essence of what's going on. We have a ramp with a fairly shallow angle of just 9 degrees that is being used to drag a stone up this ramp to a certain height. That height is to be 30 feet above the ground. The question is, what is the distance d that stone needs to be dragged along this ramp to get it to the 30 feet? Well, this is a good problem to use our right triangle trig on. We have an opposite side relative to this angle. We'd like to know the hypotenuse for the right triangle that's formed, and so the correct trig function to use would be the sine of theta, which is the ratio of the opposite side over the hypotenuse. And in this case, we know two of those three parameters. We know that the angle is 9 degrees. We know the opposite side is 30 feet, and we're asked to find the hypotenuse, which I'll denote as d here, the distance the stone is to be dragged. Well, if we solve for d by multiplying both sides by d and dividing both sides by the sine of 9 degrees, we obtain d equals 30 divided by the sine of 9 degrees, and we can use a calculator to get an approximation for the distance d. The sine of 9 degrees is approximately 0.15 or 0.156. I'll round that to 3 decimal places, 0.156. And if I do 30 divided by this 0.156, I get a value of approximately 192 feet. So the stone must be dragged about 192 feet up the ramp to get it to a height of 30 feet.